Regression analysis, running, interpreting, and reporting. The concept of regression. Regression technique is used to assess the strength of relationship between one dependent and independent variable or variables. It helps in predicting value of dependent variable from one or more independent variables. Regression analysis helps in predicting how much change, how much variance can be accounted in the dependent variable because of one independent or a set of independent variables. The present session will look into two kinds of regression, bivariate regression and multiple regression. Now, bivariate regression is just like correlation or bivariate correlation because both are designed for situations in which there are just two variables. However, multiple regression, on the other hand, is when you've got more than two variables in situations where there is one dependent and more than one independent variable. The different kinds of regressions are like correlation since they are used to evaluate the relationship among variables. This may make you think that regression is just another way to measure correlation. However, there are significant differences between correlation and regression. They've got differences in their purpose, labeling of variables, and the kinds of inferential tests that are applied. Now here are a few differences between correlation and regression analysis. There are differences in purpose of technique, the labels that we attach, and the inferential tests that we do. The purpose of correlation is association or connection between variables. However, in regression, we are predicting or explaining the dependent variable because of certain set of independent variables or just one independent variable. In correlation analysis, we do not have independent or dependent variables. We do not establish causation. But in regression, we have got a clear distinction between dependent and independent variables. The inferential test, in correlation, we are focused on correlation coefficient, that is the R value. But in regression, we've got regression coefficient, intercept, t-statistics, and change in regression coefficient. Now here are a few examples of when to use regression analysis. For example, the marketing manager wants to know if price reduction has any effect on increasing sales. The marketing manager wants to know if sales are dependent on factors like advertising spend, number of products introduced, number of sales personnel. The HR department wants to predict the efficiency of management trainees based on their academic performance, leadership abilities, and IQ level. A social activist wants to know if increasing female literacy has any impact in increasing the age of marriage of a girl child. Or if someone wants to know how much change, how much variance in life satisfaction scores can be explained by a following set of variables like self-esteem, optimism, or perceived control. Now, in each one of these examples, we've got certain keywords: impact, effect, predict, explain variance. So we are not just establishing relationship between variables. We are looking into how much change, how much variance is being accounted in the dependent variable because of certain set of factors or maybe a single factor. So what is bivariate correlation? This is the simplest regression analysis. This involves two variables. One is the dependent variable and one is the independent variable. The purpose is prediction or explanation. Bivariate regression is most frequently used to see how well the scores on the dependent variable can be predicted from an independent variable. Now, predicting the value of one variable from the other variables. Regression analysis is all about prediction of dependent variable, given a set of independent values or variables or values in the independent variables. And this is done through a regression equation. Now, for example, a marketing manager would like to predict if variation in sales can be explained in terms of variation in advertising expenditure. So how do I express, or how do we express this in the form of an equation? Here is the general format of the equation: y b0 plus b1 x I plus error terms. Let's transform this to explain this particular example. So your dependent variable is your sales. Your independent variable is your advertising budget. Your B naught is the regression constant. In this case, it explains how much sales would be there or how much sales the company will make if there is no advertising budget, zero advertising budget. So what is this B1? B1 is the beta coefficient. So if the advertising budget is $1, how much change will this bring in the sales? So this is your B1. And E here represents error terms, simply speaking, accounting for all the other factors that may affect the dependent variables but are not part of the study. So there are few important terms that are associated with regression. The first one, regression coefficient, the weight of impact, how strongly IV, also known as the predictor variable, predicts the dependent variable. There are two types of regression coefficients. One is unstandardized, the other is standardized. Now, an unstandardized is used in the equation as coefficients of different IVs along with the constant term to predict the value of DV. So when you are writing your regression equation, you are actually writing your unstandardized coefficient. Whereas on the other hand, standardized coefficient measured in standard deviation. If there is just one IV to predict one DV, the beta value would be same as correlation coefficient between the DV and the IV. So your standardized coefficient will be similar to your correlation or the R value. So there are different R values that we see in our regression equation. A simple R, this actually represents the correlation between the observed values and the predicted values based on the regression equation obtained of the DV. So R is your correlation coefficient. The other R value is R square. So when you take the square of the R, it is R square. So R square gives the proportion of variance, how much change in the dependent variable can be accounted by the set of independent variables if you've got more than one independent variables. Now R square is used to find out how well the IVs are able to predict the DV. The higher the R value, the better the IVs are able to predict the dependent variable. However, the R square values tends to be inflated when the number of IVs is more or when the number of cases is large. In order to solve this problem, we can look into adjusted R square, and it takes into account these issues. So for example, R square value is 0.70. So what does this mean? This means that 70% change in the dependent variable can be accounted by the independent variable or variables. So what is multiple regression? Wherein in bivariate regression, you had one independent variable and one dependent variable. In multiple regression, however, there are two or more independent variables. If you want to state it differently, multiple regression involves just one y variable, but 2, 3 or more independent variables or x variables. Apart from the dissimilarities, there are three similarities in multiple regression and bivariate regression. A researcher's reasons for using multiple regression is the same as the reason for using bivariate regression, that is, prediction or explanation. A regression equation is involved in both of these procedures. Both bivariate and multivariate regression always involve inferential tests. So the overall differences between correlation and regression would stand. Now let's run bivariate or multivariate regression in BlueSky statistics. Now here is my data, and I've already transformed this data. So I've got composite score for loyalty, satisfaction, image, reputation, CSR, and all. Now if you want to know how to transform, there is a video available on the channel. So if you go down there, here are your transformed variables. My dependent variable is customer loyalty, and CSR, service quality, satisfaction, image, and reputation are my independent variable. Let's just do simple bivariate regression or simple linear regression. In order to do this in BlueSky statistics, on the toolbar here is your linear regression, or you can do model fitting, linear regression, and select linear regression. Now let's do simple bivariate linear regression. I'm interested in dependent variable is loyalty and my independent variable is CSR. There's no need to do anything else, just press OK So here are our results, or when you look here, this is the model. So if you want, just like, you can copy it and put it in R and just run the regression in R. But for now we are focusing on BlueSky statistics, so let's use this. Okay, here is your R squared value and here is your adjusted R square. So in this case the R square value is 4.4843. This means that 48% change in loyalty can be accounted to CSR. So your F statistics, which is significant, these are your residuals. So there's one thing that one should note, that SPSS or any other software or BlueSky statistics or Jamovi or JASP or any other software will give you hundreds of statistics. You do not need to focus on every single one of them. There is a format that one can use to put the results in and report them. Here is the format. So I'll be talking about this in just a minute. So is CSR significant? Yes, it's significant. So what does these three asterisks mean? This three asterisks means that it is significant at 0.001 level. This is 0.01, 1%, this is 0.1%, this is 5%, and this is 10%. So this means that, for instance, 0.01, this means that there is 99% confidence that CSR will affect customer loyalty. This is your ANOVA table. Again, your values are significant. This is your F value. Okay, let's report these results in Microsoft Word, or let's see how do we report these results. So here's a format. So the problem is to investigate if corporate social responsibility has a significant impact on customer loyalty. Based on this problem, the hypothesis is there is a significant impact of corporate social responsibility on customer loyalty. Now, how do you write the results? Okay, this is not SL, this is CL. Okay, the hypothesis tests if CSR has a significant impact on customer loyalty. So first, you describe as to what the hypothesis do. Next up, the dependent variable customer loyalty, already mentioned here, was regressed on predicting variable CSR, which is obviously the abbreviation or the complete form is here, to test the hypothesis H1. CSR significantly predicted CL. So CSR significantly predicted customer loyalty. So how do I do this? This is my degrees of freedom, 768. So you just put in 768 here. So what is your F value? Your F value is 721.2662. 721.266. Let's go up to 3 decimal point. P is less than 0.001 because there are 3 asterisks. If we see here, the P value is 0, 0 is 3 asterisks, or 0.001, less than 0.001, which indicates that customer loyalty can play a significant role in shaping CL. So what is the beta value? What's the weight of impact? In this case, the weight of impact is 0.735. And your p-value, again, it is less than 0.001. Now these results clearly direct the positive effect of CSR. Moreover, the R square value. So what's your R square value? Your R square value is 4.4843. So let's use 0.4848. And this depicts that the model explains 48% of variance in customer loyalty. Now table shows the summary of the findings. Here you can write the summary of the findings. So your beta value was 0.735. Your R square values are 0.848. Your F value was 0.735. Your P value was 0.001. And hypothesis supported? Yes. Or you can, in this case, it was less than 0.001. So you can mention like this. And here you can mention now the reader would know the results or the p-value results. So let's go back here. So see, less than 0.001 with 3 asterisks, you can mention it like this, less than 0.001 with 3 asterisks. So the reader would know what these 3 asterisks mean. Now this is how you report your regression analysis. Be it any softwares, the results would be the same. Like the statistics that you get will be the same. So you can use this format for SPSS, maybe Jamovi or any other software. Now how do you run multiple regression? It's very plain and simple. So just go to model fitting, linear regression, and instead of just one, let me put in others as well. Satisfaction, image, reputation, and press OK. And here are your results. So these are the overall results. Overall, these 5 variables 1, 2, 3, 4, 5 explain 68% change in loyalty. So 68% change in customer loyalty can be accounted to these variables. So are these variables significant, each one of them? Well, this is significant. Service quality, insignificant. So service quality does not affect the loyalty of customers, but satisfaction does. This one does. And this one is also significant because it's less than 0.05. So there is 95% confidence that reputation will have a significant impact on loyalty. So this is your ANOVA table. These are your t-values which one can report as well. So this is how you can run multiple regression and use the same format. Here, just add rows in here, and you can add obviously the other results as well. Add the regression weight CSR. For example, here you can add service quality. Let me copy this from here. And this is how you can report the other results as well. Interpret them here in the text and do your hypothesis testing. So I hope this video would have helped you understand what is regression analysis, how to interpret it, and how to report it. Thank you very much.